Hello everyone. In this lecture we are going to learn about the concept of MAWP and MAP in detail. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scootoid.thinkific.com.
So today our topic is MAWP versus MAP. Okay, so we'll be starting with UG27 because that is the background for MAWP and MAP, right? So what is UG27? It's the thickness calculation formula for which shape, which kind of shape. We calculate the thickness by using UG27. Which are the shapes we can qualify by using UG27? Cylindrical and also spherical, right? C1, this formula is applicable for cylindrical, which you see on the screen. But UG27 also gives the spherical. So remember this formula, we are going to do some calculation. Unless we do calculation, it won't be very clear. Okay, so we'll try to understand by taking an example, doing some calculation, okay? So that you are pretty clear what we are discussing. So just a term which is pressure, that you have to include static head. That is the important part, which many times we miss out. Design pressure plus static head we call as design pressure. Getting it right? So the term P which you see here, if design pressure is given by client or maybe process department, that is this design pressure. You add static head and then you'll be able to get the value of P, right? Makes sense? Now, why I'm highlighting this point? Because that is a very important part when we talk about MAWP. Okay. Remember? So why it is very important? That is the main differentiation when we talk about MAWP. Okay. So up, it is without static head or with static head. Okay. So anyway, we'll build upon that. So don't worry, even if you don't understand. So moving forward, efficiency of joint is also very important parameters which you need to understand. So you have seams getting welded, right? The shell will be formed by long seams and surseams. So you need joint efficiency. Now, joint efficiency depends upon how many parameters. Which parameter will decide your joint efficiency? So radiography is enough for deciding the joint efficiency. Weld type is also very important, right? Weld type and the extent of radiography, both are required. Okay, so weld type or type number of the weld, right? It's UW12. So both are required to decide the efficiency of that joint. Okay, so don't tell only radiography. When joint type is also very important. So now let us start with the calculation. So we have a data which you can see on the screen. Design pressure, internal design pressure is 2 MPa, temperature 100 degrees Celsius, inside diameter 2000, tan to tan length is 4000, and allowable stress is 138. Same allowable you can consider at 100 degrees Celsius also. Corrosion allowance 3 mm, joint efficiency 1. And there is a static head of 0.02 MPa. What is the thickness? Now there are multiple thickness. There is a required thickness, there is a design thickness, and there is a nominal thickness. So which one it is? From formula, whatever thickness you are getting, that is the required thickness. You add corrosion allowance, that it becomes design thickness. Okay. Then you round it to purchase a plate, that is called nominal thickness. Great. So let us do that calculation together. Okay. What will be your radius? Radius 1003, clear, right? So how 1003? The ID of that equipment, whatever we are rolling, that is the ID, which is the nominal ID, which is 2000. Okay. So if I have taken, let us say 18 mm plate, 3 mm will be the corrosion allowance. Okay. So when we do calculation, we always do calculation in the corroded condition. Always the calculation should be done in corroded condition. So what will be my corroded diameter? If I have to do the calculation in corroded condition, what will be my corroded diameter? 2006, right? So half of that, 1003 is the radius. Clear, right? No problem in that, because this is the point where many times people get confused. So now the formula. Pressure is 2 plus 0.02. 1000 plus 3 is the radius. Okay. And then 138 into minus 0.6 into P. 14.81 is the right answer. Okay. Okay, so I hope this is clear. T is 14.8. Okay. Now, I'll be adding the corrosion allowance in the thickness. So my design thickness will be 14.8 plus 3, which is 17.8. Okay. And nominal thickness, I'll be getting as 18 mm. So if I purchase 18 mm plate, I'll be able to meet this 17.8 mm thick requirement. Okay. Now, if we talk about this pressure again, let us now try to build MAWP and MAP from here itself. Now, what is this pressure? We earlier spoke about this pressure is what? It's the design pressure plus static head, right? Simple. So can I say that this is the maximum pressure which your vessel can take? Can I say that? If your answer is no, then why do you think that this is not the maximum pressure? Forget about MAWP. We don't know MAWP till now. Forget about this 18 mm. Okay. Let us think first, for a few minutes that I had a plate of 17.8 mm exactly. I was lucky enough to get a 17.8 mm nominal thickness plate. I got that in the market. Now, if I'm using 17.8 mm plate, can I say that this pressure is the maximum pressure which the vessel can take? Now, can I say that? If I got a plate of exactly 17.8 mm, now can I say that this is the pressure which my vessel can take maximum? Any doubt in that? See, we are not exceeding the limit more than S value. Okay, we are limiting the stress till 138. We don't want the vessel to fail. Okay. So I know that there are some margins available, but forget about that margin. Okay, you are restricting the stresses only to 138. Getting it? So you don't have to exceed the stresses more than 138. You have to still limit to 138. Now, can I say that this will be the maximum pressure? Now, what does we mean by working condition? If working condition is coming into play, whether it talks about corroded or non-corroded, it's always end of the life. Whenever working is coming into play, guys, it is always the corroded condition which you have to consider. Making sense? Now can I say that this is the maximum pressure? This P is the maximum pressure. Can I say now? Or anything is still stopping you to say that? 138 MPa is the maximum stress which you can generate. Whenever we talk about working, that means it is in corroded condition. So 3 mm is going to corrode. If I've taken 17.8 mm, 3 mm will corrode. And finally, your calculation will be at 14.8. Okay. So if I use 14.8 here and calculate pressure now, just think about this equation. All the values are same. I'm using 14.8 as a thickness. Only P is unknown. I'm now calculating P. Okay. All the other values, allowable stress, radius is exactly same. Don't you think that P will be 2.02? See, you just calculated T by using all these values. Okay. Now I'm just saying you to calculate P by using that 14.8. S is 138. R is 1003. Don't you think you will be able to get 2.02? Yes or no? Obviously, we'll be getting 2.02, right? 2.02 will be able to get. Yes. Now, in that 2.02, 0.02 is because of static head. Okay. This 0.02 is because of static head. So, what design pressure I can apply on that vessel? What design pressure I can apply on that vessel? 2. Okay. So 2 bar or 2 MPa, not 2 bar. In this case, we are taking an MPa. So 2 MPa here is the maximum pressure which this vessel can withstand. So can I call this 2 MPa as maximum allowable working pressure? Can I say that? I'm considering I have got a 17.8 mm plate in that case. No, I'm making my vessel by using a 17 point. So can I say that 2 MPa is the MAWP? Yes. Now are you able to relate? MAWP is not different than design pressure. MAWP is exactly same as design pressure. Why it is normally more? Why it comes little bit more than design pressure? Because of this rounding which we do. Instead of 17.8, we take 18. So slightly that MAWP will be more. So MAWP, guys, is nothing but a design pressure. Okay. Calculated in this reverse manner. Is it making sense to all of you? You don't have to remember MAWP separately. It's the design pressure. Okay. Only because you have considered little bit higher thickness and that much high pressure you get. Very clear? Okay. So now, yeah. So now let us calculate in this case. Okay. Now we got 18 mm as the thickness. Okay. Now if I tell you to calculate the maximum pressure taking capability, okay, now you don't take 17.8. Now you take 18, put that here and give me. So if you are taking 18 means 18 mm as a nominal, you have to calculate MAWP. So you have to remove corrosion allowance. So take 15 here. If I'm taking 18 as a nominal, here instead of 14.8, it will be 15, right? 0.2 rounding up you did. So that much you will be getting the advantage in pressure, right? So take 15 and give me that value. Take everything same. Okay. R will be 1003. S will be 138. Okay. Only pressure is not known, which you have to calculate. Thickness is 15 because 0.2 mm rounding up, which we did. Okay. So for that rounding up, our pressure will also increase in some fraction. So we are calculating that design pressure basically. maximum design pressure. We are not calculating anything else. Now let us see how you'll be calculating. So when you are taking the maximum pressure taking capability in the working condition, that word has to be there. Maximum pressure taking capability in the working condition. That means corroded condition. Okay, working means corroded. So instead of 18, I'll be taking 15 as a thickness. Okay, and I can use this formula. Okay, now you might have also seen a formula which is written just beside it. Okay, the same formula written in terms of pressure. Have you seen in code? Same formula written in the pressure terms. Okay, you don't have to remember. You can use the same equation also, or you can use that equation. Just you can derive that equation by using this equation itself. Okay, that equation is like this. Okay, P is equal to SET. It's the same. Don't get confused that I'm using different equation. It is the same equation. Okay, if you write in this term, it will be simplified. Okay, so calculation will become simple. Now 138, 15 mm as the thickness, 1003 radius. So I'll be getting 2.04. So I think most of you got this. Now, can I say this as a MAWP? I'll reframe the question and most of you will get the answer. Is this my MAWP plus static head? Now what will be answer? Is this my MAWP plus static head? This value? Yes, right? This pressure includes static head. Remember? Now you remember why I was saying that this P is always the design pressure plus static head. Remember that? In the start itself, I has pointed out, this is design pressure plus static head. So whatever P you are getting, that will be always, I'm calculating P, right? This P. So now this P is, now this pressure, instead of calling it as a pressure, if you're just writing it as a design pressure plus static head, it is 2.04. Now, if I have to find only the pressure which can be applied at the top, so static head I need to deduct. So I'll be getting 2.02. Now, can I say that this is 2.02 MPa is my MAW? Can I say that? Any doubt in that? That is the MAWP, right? MAWP is nothing but it's the design pressure, isn't it? It's the design pressure, just it is coming little bit higher because you had taken little bit higher thickness. Okay, because you didn't get the 17.8 mm nominal plate, you get 18 mm, and because of that the pressure taking capability also has increased in the same proportion. Is that pretty clear? Now let us talk about MAP. Okay, now I'm saying, see, forget about the MAP term. Okay, I have never used MAWP term while calculating, right? I'm not saying it's MAWP. What I'm saying that it's the design pressure. Okay, and design pressure has increased little bit because of the nominal thickness. It's not different than design pressure. Remember that. Okay. Now MAP again is a design pressure. But when your vessel is completely new, okay, now you have just made the cylindrical shell and you are very curious to check that how much pressure that cylinder can take. Getting that? Just understand the emotion. Forget about the terms, MAWP, MAP, okay? You have just made that cylinder very much fresh in the shop floor. And you are interested to find the design pressure for that. How much design pressure you can apply. There is no working, so there is no fluid. You are just interested in finding the maximum pressure which it can take. That's all. When it is very new and there is no temperature, it's in cold condition, okay, on the shop floor. Make sense? So can you use this equation of P and give me the pressure which it can take when the vessel is completely new? Means it has not corroded. So what thickness you guys will be taking? 18, right? Because it is very much new. It has not corroded. Okay, you are interested in knowing that my vessel is, whatever I have made by using 18 plate, how much pressure that cylinder can take. As simple as that. Okay. You are not applying any temperature also. So definitely it's going to be in cold condition. So give me that P value. S is 138. In this case, it's not changing. So S will be 138. E is joint efficiency, which is 1. T is 18 It has not, it's very new. Okay. You want to find the pressure taking capability in the new condition. So design pressure in new condition, basically. 138 is the allowable because it's considering a carbon steel. So allowable is not changing is what we are considering. Okay. But it may happen that your allowable may change. Okay. So remember that. But in this case, consider the same. Okay. If it is carbon steel material, 100 degrees Celsius, that allowable does not change. Okay. So we are taking advantage of that and we are using the same value. So give me the value. If I'm calculating MAP, allowable is 138, thickness is 18. What about radius? Radius will be 1000. I just told, right? It's very new. So it has not corroded. So why your radius will change? It won't change, right? It's a new. So just apply the logic. If you have just made, your thickness is as it is. It has not corroded. So your radius will also not change. So your radius will be 1000. Okay. Thickness 18. Give me the value. So most of you have got 2.45. Okay. So clear? Now, some of you might be confused that whether I have to subtract static head or not. That value which you have got, 2.46. Whether you have to subtract the static head. Let us do the calculation and then we'll talk about, just first understand MAP, Dikshit. Okay. Then we'll talk about why we are calculating this. Okay. Then it will make sense. So now what I'm saying, that what is the pressure taking capability of that cylinder in new condition? There is no liquid at all. It is not in working. I'm just interested in finding the pressure which it can take. So I've used the same formula. Now here it will be 18 not 15. Okay. So I have to use 18 thickness. Radius will be 1000. Allowable, here it is not changing at room temperature because the temperature was not very high of the design. Okay. Otherwise, the allowable also may change. So what value I'm getting is 2.456. Okay. So it's new condition. There is no liquid. Okay. So P plus static head combined is 2.4.6. There is no static head at all in this case. There is no liquid, right? This is not there. So whatever P you have calculated, that is the pressure taking capability of this vessel. So 2.456 is the maximum pressure taking capability. Is that make sense? Again, it is the design pressure. Design pressure in the sense what maximum pressure you can apply. Okay. In this case, your vessel is completely new. Okay, you have just made. So there is full thickness available for you, 18 Radius will also not change because full thickness is there. And you're not talking about any working condition. So there is no static head coming into picture, right? There is no working. Static head comes when there is a working, right? There will be design liquid when it is in working. So that time static head will come into picture. Here there is no working. You are just interested in pressure. Okay, so static head will become 0. So whatever you have calculated, that is the MAP. Make sense? Now, why we are calculating this? Just to summarize why MAP is calculated. See, these MAWP and MAP are calculated for hydro testing. Okay. get the hydrostatic test pressure. There are different methods to get the hydrostatic test, okay, pressure calculation. So these are the methods which are used.
For in-depth training. And to learn more about these courses, register with the link in the description.